Today we're going to look at properties and changes in matter. Let's review a bit about yesterday's video. In the previous lesson we studied matter. We defined it as anything that occupies space and has mass. We classified matter. Looking at our classification system, we said that matter exists in one phase, and if it exists in one phase, it's homogeneous. If it's homogeneous, we decide, can it be separated by physical means? If yes, it's a mixture. If no, it's a pure substance. We then ask if the pure substance can be decomposed into simpler substances, either yes or no again. If the answer is yes, it's a compound composed of more than one element. If no, it's a pure element. If the matter exists in just one phase, if we ask that question, does it exist in one phase, and the answer is no, then we have a heterogeneous mixture. Today we're going to look at properties and changes in matter. So first let's look at properties. Physical properties specifically, we actually have physical properties and chemical properties, but physical first, properties that can be observed without changing what the identity of the matter is. So if you have a piece of paper and you tear it in two, you've changed it, but you still have paper, would be an example. We can classify physical properties into two different types, extensive and intensive. Extensive properties are those that depend on the amount of matter present in the sample that's being observed. It's directly proportional to the size of the system being studied. So this is something that when we look at it, we ask ourselves, does this property depend on how much we have? If we change how much we have, does it change the property itself? Examples of this would include mass. Obviously, if you increase the amount of matter that you have, or you have larger amounts of matter, you end up with larger masses. Volume would be another. Volume is a measure of the amount of three-dimensional space occupied. Generally speaking, the more matter you have, the more space it's going to occupy if we're looking at one given state. So we end up with some of the things that we've dealt with in class. We have rectangular solids, we have cylinders, and we can calculate volumes for all of those. We have liquid volume also. We can measure it, graduated cylinder, a syringe. This is a burette, pipettes, volumetric flasks, being just some pieces of equipment that we can use to measure volume. Area would be another. The more you have, the greater the area. So this would be a measure of the amount of two-dimensional space occupied by the sample. Number of particles in a sample also. The more marbles we have in a jar, or the more atoms we have in a sample, more than likely, the more of that material we actually have present in the sample. Heat capacity. Heat capacity is how much heat it takes to change the temperature of an object by 1 degree Celsius. And just as an example, if we had a 5-gallon bucket of water, or we have a 50 milliliter beaker of water, it's going to take more energy in the form of heat to change the temperature of the bucket of water than it would to change the smaller beaker full of water. And so more heat required because we have more matter. Physical state would be another major property that we have to deal with in this course. It is a fundamental property. As you probably have studied in previous science classes, we have solids, we have liquids, and we have gases as our three primary states. Solids, a few properties of solids. Solids tend to hold their shape. That comes from a strong force of attraction between the particles that occupy that make up the solid. So strong forces of attraction, the particles hold together, and the solid that holds its shape. Because it's holding its shape, it's going to have a fixed volume. We don't get tremendous expansion or contraction with small temperature changes. We can also, let's go back to solids for just a moment. Another primary property of solids is that the particles do move, but they tend to just vibrate in fixed positions. They don't move a lot. If they moved a lot, then solids would do things like flow. Liquids. Some properties of liquids is they take the shape of whatever their container is. They have a fixed volume. This is the reason we can measure volume in a graduated cylinder. But then they also have a fixed surface or free surface not supported by the container. So there's always what we consider to be the surface of the liquid. Liquid particles have less order in terms of their arrangement. They are moving and they're able to move by one another. So the liquid particles actually can slide by one another, but they're still in relatively close proximity to one another because they still have relatively strong forces of attraction. So only at the surface do we have significant particle movement away from the liquid itself in the form of evaporation. And then with gases, we have gases take the shape of whatever the container they're in. They completely fill the container, no free surfaces. So the volume of the gas is the same as the volume of the container. The particles are widely separated. In fact, there should be, this diagram doesn't really represent this correctly, but there should be more free space, empty space, in a gas than there are actual particles, which is the reason you can walk through a gas, such as walking through air. Particles are in rapid random motion in straight lines generally until they collide with something, then they bounce off. Intensive properties are those properties of matter that do not depend on how much matter we have in the sample. Examples of intensive physical properties would include things such as density, one that we've dealt with significantly in the last few days. It's the ratio of the mass of a sample to the volume that it occupies. And when we look at, for instance, our states of matter, we have gases, liquids, and solids. Solids are much more dense than gases, and liquids are intermediate in between the two. But at a given temperature, and that's important to say, at a temperature, temperature of course affects what state it's in. At a temperature, a substance has a constant density regardless of amount. So for instance, liquid water at 20 degrees Celsius has the same density no matter if we have a swimming pool full or if we have a 50 milliliter beaker full. Specific heat capacity is another important quantity that we probably won't deal much with in this particular class, but we do have to talk about it occasionally. This is the amount of energy required to change the temperature of 1 gram of a substance by 1 degree Celsius. So the difference here between this and heat capacity on the earlier slide is that we're looking specifically at an amount that we're changing the temperature of. So for instance, if we have equal amounts of gold and aluminum, it takes less energy to change the temperature of the gold than it does the aluminum. Gold has a lower specific heat capacity. Aluminum would have the higher. And if we compare water to either of these, water is going to be significantly higher than either of them, again with the same amount. So 1 kilogram of water would require probably about 4 times the amount of heat as 1 kilogram of water would require about 4 times the amount of heat as 1 kilogram of aluminum to change the temperature by 1 degree Celsius. Boiling point, temperature at which a liquid converts to a gas. This is an intensive property. Freezing point, temperature at which a liquid converts to a solid. Melting point, temperature at which solid converts to a liquid. In other words, all those phase change points are intensive physical properties. They depend on what the substance is, but not on how much that you have. Physical changes are changes in the physical properties that occur without changing the identity of the substance. So physical change changes physical properties. Examples of physical change include changes of state, so solid to liquid to gas, melting, freezing, boiling, condensing, and so forth are all physical changes. They're actually probably the most important of the physical changes.